This video starts with a recap of addition and subtraction, and then Professor Dave goes on to explain the relationship between addition and multiplication, and the relationship between multiplication and division.
It's easy to understand how humans developed addition and subtraction out of necessity due to the increasingly complex interactions that burgeoning civilizations required. The next operations that followed soon after were multiplication and division. Multiplication is similar to addition in that it involves the combination of two numbers to get a single number. But with multiplication, this number is not a sum. It is something else, which we can call a product. We can view multiplication as an abbreviated form of repeated addition. Let's go back to our basket of apples and pretend that we start with none. We begin to collect apples and toss them in the basket two at a time. There's two, then two more, again, and then a fifth time. So we have added 2 apples to the basket 5 times. How many are in there now? Well, apart from just counting the 10 apples, we could use addition and say 2 plus 2 plus 2 plus 2 plus 2. We could add up all the 2's and get 10. But it's easy to see how this could get very cumbersome very fast if the number of successive additions becomes more substantial. Instead, we can use multiplication. Rather than adding 2 5 times, we can just do 2 times 5. The word times means multiplication, and in this case, multiplying the 2 by 5 represents the 5 successive 2's that would otherwise be added together. 2 and 5 are called factors, and 10 is the product. Early on, we will see an X as the symbol for multiplication, but later on in our study of math, we won't see this as often. Instead, we will just see a dot, an asterisk, or even nothing at all, because when 2 algebraic terms are adjacent, it is implied that the terms are being multiplied. So if multiplication solves the problem of how to combine several identical groups of items into a single larger number, or a product, then division, as the inverse operation of multiplication, does just the opposite. It can break a larger number into smaller ones. Let's say you want 15 apples, and at the market there are baskets, each containing 5 apples. How many baskets should you take? We simply divide 15 by 5 per basket to get 3, which means that 3 baskets will give us all the apples we need. 15 is the dividend, and 5 is the divisor, while 3 is the quotient. So multiplication gives us a product, and division gives us a quotient. With division, early on we see this symbol, but later on this will almost never be used. Instead, we will see a line, either at an angle or horizontal. With this kind of notation, the first number will be divided by the second. We should note that multiplication, like addition, is commutative. 2 times 5 is the same as 5 times 2, because whether we have 5 piles of 2 apples or 2 piles of 5 apples, we have 10 apples in total. Division, however, like subtraction, is not commutative. 10 divided by 2 is not the same as 2 divided by 10. Also, multiplication is associative. 2 times 3 times 4 will be 24, no matter which numbers are multiplied first. We could do 6 times 4 or 2 times 12. It doesn't matter. Division, however, is not associative. 10 divided by 5 divided by 2 will provide a different result depending on which number is divided first. This is not arbitrary. We defined these operations and then observed whether or not they abide by commutativity and associativity. So there we have the 4 basic arithmetic operations: addition, subtraction, multiplication, and division, as well as some of the properties of these operations. The more we practice them, the easier they become, and it may be of some use to memorize the multiplication tables. Remembering offhand that 8 times 7 is 56 is not only faster than using a calculator, it should also be a mild source of pride.
Thanks to Professor Dave for that great explanation. Now log into your Socrative student account and have a go at the multiplication and division quizzes.